There are a couple of questions coming in about the extent of the deforestation that could be linked to artisanal and small scale gold mining. So the questions are: have people quantified this loss? Is that information available? And then a third the third question is what have governments or organizations done to rehabilitate these areas, if anything, and maybe also comment on the scale of those rehabilitation efforts.
Sure. I can take a crack at that one.
Okay.
We do a fair amount of work on this. So the first question was, has the deforestation specifically from gold mining been quantified? Yes, in the Amazon there has been earlier in, let's see, December of last year or January of this year, there is a group called RISEG, which is, I can ask Barbara to post the links to these maps, created a map. It's a consortium of spatial experts that compiled satellite imagery in 2017 and 2018 to figure out the extent of artisanal gold mining across the Amazon, and produced a very detailed map about where it occurs and its conflicts with native communities and protected areas. And that was the first time that it was done on the continent scale. I'm sure that it was covered by the New York Times. It was in the cover of the Washington Post, Manga Bay. So that was the first time that you saw the big picture. But many people have been working at smaller scales, trying to map where it is. Actually, in my research group, we created a map of artisanal gold mining and basically the deforestation created over 35 years, from 1985 to 2017, by analyzing high resolution satellite imagery every year that it was available. And we quantified not only what's been lost today, but basically kind of the lifespan of mining and how it's grown and how it's linked with the price of gold. So when we plotted essentially that bar chart, you can imagine like little bars in 85 and it grows bigger and bigger. When we laid the line of the price of gold, it tracked almost perfectly. The correlation was extremely close, and it gives you the real picture in one graph. When the price of gold goes up, you have deforestation from mining increasing, not just in Peru, but across the world. That relationship holds. Many other organizations have mapped this. We actually created and published in a scientific journal a new methodology to specifically isolate mining because there's special characteristics. So we have a really robust method of separating it from small scale agriculture or cattle ranching or logging. So we can now start to automate it. So what we're doing is we're creating machine learning tools. We're using algorithms to automate the detection of this, not just in the place where it works, but we can apply it across the Amazon and in Africa and Asia. Once we use essentially what's very similar to facial recognition algorithms, basically using computers to supercomputers to analyze where you see the mining equipment on a landscape. And that's a really good indicator of where, not just where the mining has occurred, but also where the mining will occur in the future. So there's a lot of new technology, new innovation that's going into analyzing, detecting this. In terms of what happens afterwards and whether or not governments are doing something about it, I would say not enough. The challenge really is not just that you have an area that has no trees. It's an area that's mined. It's very similar. It's a strip mine, essentially. It's a complete loss of all the soils and much of the mineral soils underneath it, and that could go down 5, 10, 20 meters. And it's surface. So basically they're scraping it and then processing the first 30 to 40 feet, 10 meters, 10 to 15 meters, sometimes deeper. And there you have basically, it's not even soil, it's basically just sand and cobbles and gravel. So that doesn't have a lot of nutrients. It doesn't have any carbon to be able to provide the ability to absorb water or to retain nutrients. So you really have to do several things. You have to build back the soils, and you have to select native species that can withstand essentially being transplanted in the middle of a desert. And this was a rainforest before. Um, there are trees that you could plant that will grow in that kind of climate, but they're not rainforest trees. Essentially, you're getting these invasive species and putting them in an area that was supposed to be a rainforest. So I personally have a problem with that. If it's a rainforest, you want to bring back the rainforest, at least try to accelerate it. So there's been a lot of work done with native species, figuring out which are the pioneers that can go in there, and then create conditions to help them reestablish the forests. And then mix in species that will be the big climax, the species like you saw the Brazil nut tree that the Goody liked. You have to throw some of those in the mix. They grow slower, so by the time the fast-growing trees reestablish, they'll have some shade, and those slow-growing climax trees will have a chance at reestablishing the forest. Because once you reestablish the forest, then you can hope that the animals will come back. And again, this is something when people talk about reforestation, we're not building tree parks. We want forests that have animals in them, because that's what they're supposed to have. Also, native people require non-forest timber products and animals to hunt if they're still living traditionally. So you need to use the native species from the region to reforest areas to restore the animals to life back into that forest. And just to finish up, again, there needs to be a lot more work. We've worked on essentially reforestation methods where we basically do lots of experiments figuring out what species work and where, and how to create situations to bring back that soil using technologies like biochar, which is a special kind of charcoal, special planting methods that make it more probable, and the use of like high-tech nurseries, so that you can produce the millions of trees that you need to reforest 100,000 hectares that have been deforested, for example.
Thank you, Luis. Daniel, I noticed that you were posting some links in the chat. Would you like to address the question and what you posted?
Sure. Thank you, Louis. That was a great intervention. And I just threw some links there for the panelists and the attendees of those Amazon mining mapping groups that Louis was mentioning, because I was also looking at those just in preparation for this. And both of those resources are really good ones. Different groups of researchers that are making maps public, and looking also at the drivers of the reforestation, and trying to separate out, as Louis was also mentioning, that his group is doing the mining from the other sources of deforestation. So there's a lot of really great maps there. And it's really worth mentioning, this type of effect, I think, before I go into a bit of a different tangent, that this type of mining where they need to tear all the trees down is really the result of this certain type of gold deposit. And as I understand it, the Conservation X Challenge is not reserved sort of for the Amazon. It's not geographically reserved. That's correct, isn't it?
Right, correct.
Mm-hmm. And so, this type of alluvial deposit where the Amazon forest is getting really mowed down to access this kind of gold in the gravels below the rainforest, is just one of the types of gold deposits, and is really prevalent in the Amazon. Less prevalent in the Amazon is the hard rock mining, although in other parts of the Amazon, actually, it is sort of the more typical hard rock mines that you see. Parts of Colombia, you see a lot of hard rock mining, and that's what we see in many other countries as well, where we don't have the same type of ancient alluvial benches. All that gold in the cobbles below the rainforest is actually the result of over geological time, over hundreds of thousands of years, of course. There's rivers moving. So that's secondary gold deposit that was initially coming down from the mountains or the hard rock as it weathered, getting deposited in the gravels of these rivers. And over geological time, rivers move, hundreds of kilometers east to west, north to south. And so you have this ancient alluvial gold stuck in these alluvial benches that are now covered with rainforest soils. And that's what the miners are going after. So it's quite different from the hard rock context, where the impact on an environmental scale is quite a bit different. But interestingly, you still have the quite intensive, in many cases, use of mercury, because they bring that rock out of the shaft, let's say, and they crush the rock. In some cases, including in the Amazon, they add an awful lot of mercury, even more mercury to this type of rock, because they actually add mercury to the entire ore as they crush it. And that's not ubiquitous in the Amazon, but it is also very typical there. And that's one of the, if we're focused on the mercury challenge, which, to your earlier question, is one of the things that I think, Conservation X is also looking for solutions around, is really we should focus on those operations where they're using an awful lot of mercury. And that's what we call whole ore amalgamation, where they're literally putting mercury in volumes in order to process the entire ore, so all of this hard rock. And of course, all of that, most of that mercury that they're adding, it gets cooked after they form an amalgam, which is then, the mercury acts like a glue for the gold. And so then they have the mercury with gold inside it. They want only the gold, so they heat it, they cook it, and it burns off the mercury as fumes to leave the gold behind, which then can be sold on into the supply chain to the traders. And so most of that mercury goes up in smoke. And the fate of that mercury is being studied by a lot of researchers. A lot of it is deposited locally based on weather patterns. A lot of it gets deposited, in the rainforest and in the community around. And so there's a lot of acute health, concerns, of course, for the immediate community. But as Louis was also mentioning, and was mentioned in the film, you have this really, serious concern around the local food chain, around local fish. If the mercury effluent from these operations is going into the streams. And it's worth mentioning, I guess, that we have this large international convention, the Minamata Convention, which is specifically targeting mercury. And so we actually have, and I think this new convention, international convention, it's a UN convention, more than 150 countries have signed to it. It's a really important opportunity, and for Conservation X Challenge to engage with all the organizations focused on solutions for the mercury challenge. I'm also really passionate about the reforestation piece, and so in the context of the film and this big issue of the Amazon being destroyed, it's really an interesting challenge. And before I go on to the mercury abatement, I'll say a few words quickly just about that, but Louis has covered it very well already. In fact, in my university days in Canada, I was very involved in tree planting. And so I also have some knowledge of the silviculture industry in Canada. And it did go through a big, a process of maturation and transformation, where it used to be that the forestry companies were literally planting a monocrop, just farming the trees essentially. And that is still the case in some areas, but in other areas, they're doing more to try to reforest in an ecologically sensitive way. So you have, maybe 4 different species as a tree planter on you at any time, and you need to really select the microsite for those species. And as Louis was saying, it's succession, which means, starting with species that will grow in this degraded climate is critical, especially because, as Louis was saying, you're losing the very top of the soil horizon, which is really in the rainforest, the most critical one, where a lot of nutrients and organics are stored. And so I think actually personally that I've been thinking about this even when I was recently in Indonesia, that the Conservation X Challenge may be really well suited to some pilot project focused on exactly this challenge of how can we ensure that new species are able to take up? What are the conditions we need to set up? Obviously, one of the really biggest challenges is erosion in this sandy soil. And the rains, when they come in these climates, they come hard. And so there's no organic matrix for the young plants to hold on to. And so, we have to think about what are the actual, what are the reforestation challenges we can find technical solutions for. I think that's a really exciting opportunity for the Conservation X Challenge and applicants in their ideas. As for mercury abatement, maybe I'll quickly talk that. You know, one of the major alternatives, which is being taken up all over the world, is also the major chemical that large-scale mining companies use, and that's cyanide. And now cyanide is a very toxic chemical as well. It's toxic in a different way than mercury is. But if used responsibly, it can in fact be quite, environmentally manageable, let's say. It's essentially a carbon and nitrogen atom, but with a unique sort of triple bond. But it has unique properties for that reason, the cyanide atom, or cyanide molecule, I should say. In any case, the important thing, again, as it is with the financial and the formalization barrier, is the question is how can we support artisanal miners to use these new methods responsibly? You know, in addition to cyanide, there's other leaches. A lot of groups have been, hoping for or looking for maybe a miracle chemical that was, environmentally benign, and then could completely eliminate the use of mercury, and that has not been found. There's certain leaches which can work, but they usually work in very sort of specific conditions. Hydrogen peroxide in some cases can work, hypochlorite, sodium nitrate, but in various chemical combinations, and really ultimately those other solutions typically require a lot more technical knowledge. The reason mercury is so ubiquitous in the small-scale gold mining sector all around the world is because it's so easy and so quick and ultimately incredibly affordable. Even now, with the new minematic convention, we see the price of mercury increasing as a result of trade constricting around the world. So now a kilogram of mercury costs between $100 and $200, depending on where you are in the supply chain. Usually for miners, it's closer around the $200 per kilo. But they're not buying a kilo, they're buying 15, 20, 100 grams. It's really dense. So even a bottle cap is about 100 grams. But the point is, that 1 kilo that costs them, around $200 is enough mercury for them to produce around 20,000 US dollars worth of gold. So it's, mercury, yeah, it's a cost, it's a concern, but it's like 2% of their costs in terms of the gold they're producing. So ultimately, it's cheap, it's quick, and it's super easy. It takes them 15 minutes at the end of the day to process the gold and really get it out of the sediment using mercury. It's a really major challenge, and it's difficult to contend with. So ultimately what's needed, and this is ultimately a call for Conservation X applications, is, and this is something we've also been working on at PACT, is systems which is essentially it needs to be a business model. It needs to work for the artisanal mining community such that, if it's a heavy mineral concentrate at the end of the day, that they have a way to, responsibly, safely deal with getting the gold out in a way that's economical. Because if there's no economy for them, if it's not incentivized in some way, and can't do what mercury does for them, it's very difficult to support the behavior change that's required.